All right, let's do this. So you see the radical, you see x squared. So perhaps you're thinking trig substitution, but it's not in the correct form. So that's where we want to fix this by completing the square. So I'm going to take these first two terms, move the 13 over to the side, and I'm going to complete the square on these, right? So x squared, sorry about that, minus 6x. I'm going to take half of 6 and square it. So I'm adding 9, and then I'm going to carry this 13 along, and I'm going to subtract 9. Remember, you have to add and subtract to not make a change in the problem. So this turns into x minus 3 squared plus a 4. Okay, so that's what goes back into the radical. So square root of x minus 3 squared plus 4 dx. Okay, so let me erase this. So after you complete the square, you're expecting to do trig substitution. So I'm going to suggest that you do a u substitution. Let's let u equal x minus 3. So that means du is dx. So this just turns into du u squared plus 4. All right, so what do we do with that? I see it. You do too. So u equals 2 tangent of theta. Du is 2 secant squared of theta d theta. So you know this explodes, gets large. 2 secant squared theta d theta over, and then I put the u in, so I get 4 tangent squared theta plus a 4. And you know you're expecting always inside the radical will be an identity. So let me bring it over here. So I'm going to pull that 2 outside, keep that there. Okay, so if I factor out a root 4, which is like a 2, tangent squared theta plus a 1, there it is. That's the identity. So this 2 over this 2, right? I'm just going to erase them and just say it's 1. Okay, so integral secant squared theta d theta, and integral, to take the square root of tangent squared plus 1, let's just go slow. So that's like saying secant squared of theta. Well, secant squared over a secant gives me just a secant of theta plus a c. Okay, now you're looking towards getting back to x's, right? And so the transition is this original substitution. So I'll put the x's in at the very, very end. So I'm going to rewrite this, and this gives me u over 2 is tangent of theta. So let's make the triangle, right? So here's my angle. So opposite over adjacent. And then this side will be u squared plus a 4. So then what do we know that secant is? Secant is hypotenuse, u squared plus 4 over adjacent plus a c. And then we get to, oops, I'm sorry. I meant I needed to do an integral of secant. Oh, dear, dear, dear. Okay, hold the horses here. So I dropped the integral sign, didn't I? D theta. Okay, integral of secant. Oh, you know this. It's integral of secant of theta plus tangent of theta plus a c. Okay, I still can use my triangle. I just needed to erase it to make room. So this would be opposite over adjacent. So this is my hypotenuse. So I get ln secant, which is hypotenuse over adjacent plus tangent, which is u over 2. And then the very last step here is to replace u with x minus 3. So I get ln, absolute value, x minus 3 squared plus 4 over 2 plus x minus 3 over 2 plus a c. Okay, so that is how you would approach this one. So you're recognizing a quadratic inside of a radical that motivates you to complete the square so that you can do a trig substitution. Kind of knowing where you want to go is a big part, and like choosing what to do. This example 2 here looks like partial fractions to me. All right, so let's do it. 4x, x minus 1, x squared plus 9. So I'm going to have an a over the x minus 1 and a bx plus a c over the x squared plus the 9. So I'm going to multiply both sides by this, right? And then this side here, x minus 1 times x squared plus 9. So this always, these cancel, so the left-hand side turns out to be the numerator. On the right-hand side, when I multiply this times this term, I get a times x squared plus 9. And then when I multiply this times this term, the x squared plus 9 go away, bx plus c times x minus 1. So it's really important you put the parentheses there. Okay, so now, is there a good number? You always want to check and see. Yes, there's one good number, x equal 1. So let's do it. 4 equals, and this would give me 10a. And by plugging in x equal 1, that's 0. So I get a is equal to 2 over 5. Save that. Now, since there's no other good numbers to plug in, I need to think about comparing coefficients. This one's tricky, so you might want to take the time to multiply this out. So I'll carry this along. And why don't we plug in the 2/5 for the a, right? We know it. 2/5 x squared plus 2/5 times 9. I'll just leave it like that. And then it's very easy to make a mistake with this. So I'm just going to multiply it out. So I get bx squared, this little bx squared minus bx plus cx minus a c. All right, so what am I trying to find? I'm trying to find the b's and the c's. Well, let's see. I've got a bx squared and a 2/5 x squared. What's the x squared term over here? It's 0. So comparing the x squared terms, I'd get 0 is equal to 2/5 plus b. Well, there you go. b is equal to negative 2/5. Okay, so now we need to go check either the x terms or the constant terms. You get to choose. So I'm going to go with the x terms. So the x terms on the right-hand side, I get a negative b plus a c, right? Those are the only two x squareds, and that equals 4. Okay, so I get 4, and I'm going to put the b in, so that would give me positive 2/5 plus a c. So then adding that, so c is equal to 4 minus 2/5. So c is, fractions are your friends, right? So I get 18 over 5. I think that's right. Okay, so then I plug all of these numbers in. Okay, so let's plug all this information in. So I get a 2/5 over an x minus 1. The b is a negative 2/5, and I put that in front of the x. And then I get an 18/5 over an x squared plus a 9 dx. Okay, I want you to be careful because there's a mistake that can be made here, and I don't want you to do it. It would be so easy, you can put it in red, it would be so easy to say, oh, I'll take that negative sign and put it in front, and then do this, plus 18 over 5, and then x squared plus 9, plus 9. That would be incorrect. So this negative is just on the 2/5. By putting it out front, you're saying that it goes to both of them. It doesn't. So don't do that. So I'm just going to encourage you to just go slow with the pulling the numbers out in the front. So plus. So, or I actually even can say, now I can pull the negative 2/5 out in front, x over x squared plus 9, plus 18 over 5, 1 over x squared plus 9 dx. Now I can go do the antiderivative. So this gives me 2/5. That's easy, ln. You're good with that. I think you're getting good at u substitution, right? So you can see this is going to be a du is 2x dx. So I'll get a negative 2/5, a 1/2. This will be 1 over u du. And so then I can take the integral, ln, and you see it. There it is, arctan. 18 over 5 with a 1/3 arctan of x over 3 plus c.